Hi everyone. Today we're going to do section 3.1, 3.2, and 3.3. Okay? So in section 3.1, in those three sections, we are doing system of linear equations. To begin with, here is what I'm going to have you do, okay? I'm going to give you a linear equation. For example, this one, look at this one. It's a linear equation. Okay? All right. A linear equation is this: 6x minus 7y equals 8. 6x minus 7y equals 8. Okay? Now, I'm going to give you another one. Okay? I'm going to give you another one. And that's why we're going to call this a system, because it's going to be more than one equation. Now, if I give you two equations, both equations must be with two variables, okay? All right, so that's the first equation. We can graph this equation. Yes, we can. We can graph it, okay? For example, if x is 0, x equals 0, plug in 0 there. What is 6 times 0? 0. If x equals 0, then we have negative 7y equals 8. Look at this. Negative 7y equals 8 if x equals 0. Right? And when you solve for y equals to, divide both sides by negative 7, negative 8 over 7, which is negative 1 and 1/7. Okay? So, a solution to this equation, a solution is going to be x equals 0, and y is negative 8 over 7. Okay, and negative 8 over 7 is negative 1 and 1/7. Correct? Okay. Let's do another one. Let's find another one. What if y equals 0? If y is equal to 0, then this is 0. Correct? And so then 6x equals 8. 6x equals 8. So for x, so that x equals 8 over 6. Simplify that. 2 goes into 8 4 times, and 2 goes into 6 3 times. So this is 1 and 1/3. So that's another point for this one. Another point. Okay, if y equals 0, look, y equals 0, right there. That's the second value in the coordinates, right? X is 4/3. We can graph the points. We can graph these 2 points. So here is x, right here. This is x. And this is y. And we can graph the points. 0 for x, and negative 1 and 1/7 for y. That's negative 1, negative 2. So if x is 0, y is negative 1 and 1/7. Right? I'm going to say right around there. That's the first point. If x is 0, y is -1, and 1/7, -1 and a 7th, okay? Here, when y is 1 1/3, when x is 1 1/3, y is 0. When x is 1, x is 2, this is 1, this is 1 1/3, this is 1 2/3, this is 1 3/3, which is 2. So right there, when x is 1 1/3, y is 0, right there. Okay? Connect those 2 points. Connect the points with a straight line. And there you go. So this is the first equation. This is this equation. Okay, I found 2 points, and that's the way I found them, okay? I need the room, so therefore, I'm gonna erase this. There you go. Now, we know how to do this. But in section 3.2, you have more than one equation. I'm sorry, in chapter 3, we have more than one equation. More than one. That's what we call it, system of linear equations. So let me include another equation. Here is another equation. The other equation is this. 2x plus 7y equals -16. 2x plus 7y equals -16. And this is going to be equation 1. And now this is going to be equation 2. And now we have more than one linear equation. So now we're going to call it system of linear equations now, because it's more than one. Okay? All right, very good. This is a system of linear equation. No, I graphed this one. I graphed the first one. Well, guess what? I'm gonna graph the second one. Okay? How do I graph the second one? Let x be 0. Do the same thing. If x is 0, I'm going to write 0 for x. I need to get y. Okay, I can do that. If x is 0, this term is gone. So that 7y equals to, that's a y, equals to -16. So that y equals to -16 over 7. And how many times does that? 7 goes into -16 or 16. So this is negative, how many times into 16? Twice. What's 2 times 7? 14. Plus 2, 16. Right, so this is 2 2/7. So when x is 0, y is -2 2/7. But we don't write it like this when you write it in as a point. Just write this, okay? So therefore this is -16 over 7. We know what it is. It's -2 2/7. Okay? So we found a point. Let's find another point. Now let y be 0. Let y be 0 there. If y is 0 right here, if this y is 0, you cover that, because what's 7 times 0? 7 times 0 is 0, so that's gone. If y is 0, this term disappears. And so if y is 0, if y equals 0, right? This is 0, then we have 2x equals to negative 16, which means what? X equals to what? What's negative 16 divided by 2? Negative 8. Okay, so if y is 0, x is negative 8. And there we found 2 points to the second equation. By the way, this is not the only way to graph them, okay? Another way to graph them is to write them in slope-intercept form. Okay, very good. Very good. And so now, let me graph the second equation. Okay? So, if x is 0, y is negative 2, and 2/7. Look. If x is 0, y is negative 1, negative 2, negative 3. So if x is 0, y is negative 1, negative 2, negative 3, and, negative 1, negative 2, and 2/7, right? So negative 2 and 2/7, I'm going to say right around there. Okay. Let's graph this one. If x is negative 8, y is 0. If x is negative 8, y is 0. X is negative 8, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, and negative 8. Y is 0, right there. So now I have this point and this point to the second equation. I'm going to graph those 2 points. I'm going to pass a straight line through them, correct? All right. So here we go. And that's going to be the graph of the second equation. So please understand, this equation, it goes forever and ever. Okay, and this equation is 6x minus 7y equals 8. And this one here is going to be 2x plus 7y equals to negative 16. Okay? And you guys know how I got them. Okay? So let me erase this. So in this chapter, the aim is to find out this point. The point equation 1 and equation 2 have in common. Why? Because at this point, there is a party. Or you may call it a fiesta. Right there. And who don't we want to go to a fiesta, a party? Yeah, we do. Okay? So therefore, class, we want to find this point, because once we find this point, then we have found the party. Okay? Once you find this point, you have solved the system. So we're going to say solve the system. And what does that mean? It means find the point both lines have in coming. Okay? And you can find the point by graphing, okay? The problem with graphing is that you're gonna have to guess. Okay, you're gonna have to guess this point. That's where the party is. The fiesta. What do you think this point is? It looks like this point, the coordinates for this point is gonna be x equals to, I don't know, maybe -1, x is -1, and y is -2. That's a wild guess. Actually, it's not a wild guess. It's a good guess. Okay? So I'm going to say that the party is where? At x equals -1, comma, and y equals -2. That's where the party is. Okay? All right. So you can find the address to the party by graphing. That's one method. But that's not the best method. Why? Because some of the points that two lines may have in common may be fractions or may be decimals. It's going to be very hard many times to guess with exactness what those fractions are. So therefore, we can find the address to the party by graphing, but that is not the best way. There's another way. Okay, there's another way. We can try to find the address by the substitution method. Okay, so I used this already, okay? You guys have it. So let's do it by the substitution method. Substitution. Method. Okay? So with the substitution method, all you have to do is pick an equation and solve for a variable. Okay? Pick an equation, solve for a variable. One, pick an equation and solve for a variable. Okay, which equation is up to you? Which variable is up to you? So I'll pick equation, I think equation 2 is easier to solve. I'm going to solve for y in equation 2, okay? I could solve for x. Okay, but I'm going to solve for y. So I'm going to say solve for y in equation 2. Okay. Solve for y, here is equation 2, solve for y. Bring this over. So we have 7y equals to, bring it over to the right, negative 2x minus 16. Actually, you know what? I think I'm going to change my mind because I'm going to get too many fractions. Yeah, you know what? I'm going to solve for x instead. I can do that. I can do that, okay? I can do that. I can change my mind. I'm going to solve for x. It's easier. So instead of y, I'm going to get x by itself, okay? I think that's better. So if I'm going to solve for x, bring this y to the right. This 7y to the right. So 2x equals to negative 7y minus 16. Yeah, that's what I wanted. Almost done. Solve for x. How do I solve for x? Divide everything by 2. Divide this by 2x. Divide this by 2, negative 7 over 2y. Divide this by 2, what's 16 divided by 2? 8. Got it. Don't forget this equation too. That's the first step. Second step, substitute or plug in. Substitute. The isolated variable in step 1 into the other equation. Okay, so I'm gonna substitute the isolated variable in step 1. By the way, this is the substitution method. That's why we call it the substitution method, because we substitute. So I'm gonna substitute the isolated variable. That's x is the isolated variable. I'm gonna substitute this x into the other equation. So this x comes from equation 2. The other equation is equation 1. So here's equation 1. This x is going to be substituted. Okay? So equation 1 says 6 times x. That's going to be my x right there. Minus 7y equals to 8. And what is x? X is this. Minus 7 over 2 y minus 8. Okay. Step number 3, solve. Solve for the variable in step 2. Solve for the isolated variable in step 2. Okay? To solve for this variable, I'm going to distribute, okay? Distribution. I'm going to multiply 6 times negative 7. I'm going to go here. 6 times negative, what's 6 times negative 7? Negative 42 divided by the 2 there, y. What is 6 times negative 8? 6 times 8 is 48, so this is negative 48 minus 7y equals 8. Okay, there you go. All I did was multiply. 6 times 7 is 42. 6 times 8 is 48. And they're both negatives. 2 goes into negative 42. How many times? Negative 21y minus 48 minus 7y equals 8. Okay. What is negative 21y minus 7y? What is that? Negative 28y minus 48 equals 8. How do you solve for y? Well, bring this over. What is 8? This becomes positive. What is 8 plus 40? What is 8 plus 48, I should say? 8 plus 48 is 56. So negative 28y equals to 56. Okay? Divide both sides by negative 28. What is 56 divided by negative 28? Y equals negative 2. Yeah. We got this part. Okay? We're not done. Okay? Remember, when you do it this way, you don't have the graph. Because unless we tell you graph it, you don't have to graph it. So therefore, you don't have this graph. If you do the substitution method, you don't have this graph. So let's cover the graph. And so therefore, if you get y, the question is, what is x? Because you don't have the graph. Unless you want to graph it, you can. Okay? So therefore, once you find the first variable, it could be x or it could be y. In this case, it is y. Then you have to find the other variable. And how do you do that? Well, let's take this y equals -2 and let's plug it into one of the equations. Yeah. -2, you can plug it in either or. Y equals -2, you can go there. If you go there, it's the same thing as going here. I'm going to go there, okay, just to satisfy you guys. Watch this. If y is -2, I'm going to go to equation 2. So equation 2, so let's do this, okay? Let's do this. Equation 2 says 2x, what's 7 times -2? -14 equals to what? -16. What is -16 plus 14? So 2x equals to what? -2. Divide both sides by 2. So that x equals to what? -1. Yeah! We were right. We got the other one right there. Okay? And so therefore, remember, you don't have this graph. If we ask you to do it by the substitution method, you don't have this graph in the back. But look, you got y equals -2, x equals -1. So then you say, the solution has been solved. We found the address to the party. The address to the party is this. It's the solution. Solution is for this party, for this system of equation, the solution is -1, -2 is the solution. Or you may call it, I'll let you use the word address to the party. There's the party. Look at the same thing. Okay, very good. So this is the substitution method. So now we have a second method. The first method, graph. Is that the best way? No. Because sometimes the answers are fractions. And here, remember, we guessed. We were right here because these were whole numbers. But if the answers are fractions, it's going to be hard to guess. So therefore, that's not the best way. The second way, the substitution method. And here it is. The third way, the elimination method. Okay, so this is gone. So I'm going to show you a third method. And most people like the third method. The third method is the elimination method. They also call it the addition method. Okay, so now this was the substitution method. Now let's do the elimination method. That's method number 3, elimination. Method. Okay, all right. Just what it says. Let's eliminate a variable. What you're going to do to eliminate a variable is you're going to add both equations. When you add both equations, you pick a variable to eliminate. You can eliminate x, you can pick x to eliminate, or you can also pick y to eliminate. Pick one of them. Whichever is convenient, okay? You're going to eliminate a variable by adding both equations. Now, if you're going to eliminate x, you need to make sure that the x terms in both equations are opposites. If you decide to eliminate x. You can also decide to eliminate y. I look at this equation and I see this negative 7y and I see this positive 7y. Hey, this is almost ready. So therefore, I'm going to eliminate y because those two are already opposites. So therefore, eliminate y. That's convenient because those two are already opposites. This is negative 7y and this is positive 7y. Yes, that's the best way. How do you eliminate y? Like I said, add both equations. You better line up the y terms, and you better line up the x terms, and you better line up the constant terms. They should be lined up vertically. So equation 1 and equation 2, line them up. 6x minus 7y equals 8. Okay? Sometimes you have to do a little bit of work to line them up. Not in this case. Equation 2 is 2x plus 7y equals negative 16. Add them up. That's what it says. Add both equations. This is to eliminate y. Watch. Look how beautiful this is. Watch this. What's 6x plus 2x? 8x. What's negative 7y plus 7y? 0. What is 8 minus 16? Negative 8. Oh, look at that. Look at this beauty. Let's divide both sides by, look at this. 8x equals negative 8. Divide both sides by 8. Divide this by 8, you get x. Divide this by 8 and you get negative 1. And yay, we got the first value of the solution. Look. Now you can do what we did earlier. Now you can take this answer and plug it into one of them. I already did it for you guys. But there's a better way. Instead of doing that, let's eliminate x. Watch this. Let's eliminate x. Okay? You can take this and you can plug it in there and you can solve for y. But another way, which is going to come in handy later, is going to come in handy, especially if the answers are fractions. The way I'm showing you right now is more handy. Okay? Now I'm going to eliminate x. Here I eliminated y. Now I'm going to eliminate x to find y, the answer for y. That's going to come in handy later. You can plug it in and solve for y. You could do that. It's easy, right? But instead, I'm going to do this, okay? Remember this. Sometimes this is going to be a better way to do it. Eliminate y. No, eliminate, here eliminated x, y, I'm going to eliminate x. Now, if I'm going to eliminate x, these two need to be opposites so that I can add both equations. They need to be opposites. Well, that's not too bad, because if I multiply this 2, x times negative 3, that's going to give me negative 6x. But I cannot just do it to this term in this equation, I must do the entire equation. So, okay, I can do that. I'm gonna take equation 2, look at this, I wanna make it the opposite of this. So the opposite of that, I'm gonna multiply this by -3. I gotta multiply the entire equation by -3. Okay, let's do it. What's -3 times 2x? -6x. What's -3 times 7y? -21y. What's -3 times -16? Equals to 48. Okay, that's -3 times equation 2 right there. Multiply all of them. Equation 1 stays the same because I want those two opposites because that's what I want to eliminate. So equation 1 stays the same. That's a 6x minus 7y equals to 8. Remember, this is going to come in handy. Add them up because that's what you do, add both equations. Those two cancel each other. That's 0. And what is this? -28y. And what is this? 56. Does that ring a bell? Divide both sides by what? Divide both sides by what? Divide this by -28. Divide this by -28. And so, what is y? -20 cancel. -28 into 56 is -2. And there it is. Okay. So which method do you like? The graphing method? That's not the best way. The substitution method? Okay, it improved, but most people do not like the substitution method. Most people like the third method, the elimination method. Okay. Very good. So let's look at another one. It's our system of equations. Okay? So we're solving system of equations. Okay? Here's another one. Solve. Solve the system. Solve, I'm going to say 15a minus 2b, 15a minus 2b equals to -9. The next one is 5a minus 5b equals to -29. Okay? All right. So you pick a variable to eliminate. I'm going to pick the easiest variable. This is equation 1, and this is equation 2. And look at this. A, if I eliminate A, I only have to multiply this equation 2 by -3. Because what's -3 times 5a? -15a, the opposite of that. So A is easier to eliminate first. You can eliminate B. If you decide to eliminate B first, look, you gotta multiply this -2 times 5 and this -5 times -2 because they need to be opposites. So I think I'm gonna eliminate A first. Eliminate A. Okay, no problem. Equation 1 and equation 2. I'm going to multiply equation 2 by -3. In equation 1, it's going to stay the same. So equation 1 is 15a minus 2b equals to negative 9, okay? And equation 2, multiply this by negative 3, negative 15a by negative 3, guys, okay, by negative 3. What is that? Is that plus 15b, and then by negative 3. What's a negative? It's a negative, positive. So 3 times 9 is 27, takes 2. 3 times 2 is 6 plus 2 is 8, and it's positive. There you go. Okay, very good. Okay, add them up. Okay, so I'm gonna add both equations, okay? All right, no problem, I can add them up. What is this? 0, and what is this? 13. 13b equals to, let me see, 87 minus 9. Okay, 80, and then 2 more. 87 minus 9 is gonna be, is that 78? 78. All right. Okay, so let me see, 17 minus 9, yep, that's right. So now let's divide both sides by 3. Let me see if I wrote it correctly. Negative 29. Okay. All right. Very good. Okay. Divide both sides by 13. Divide this by 13. Divide this by 13. The 13's cancel. And b is equal to what? How many times the 13 goes into 78? Is it 6 times? 6 times 3 is 18, takes 1, and 6 times 1 is 6, plus 1 is 7. That's right. All right, now I can take this B and plug it into one of them, and I'll get A. You can do that. All right, let's do that. Let's do that. Just for you guys, let's do that, okay? So watch this. I'm gonna plug it into this one. Yes, that's what I'm gonna do. So equation 2. So 5a minus 5b, what is b? 6 equals negative 29. What's negative 5 times 6? So 5a minus 30 equals negative 29. Add 30 to both sides. So 5a what is negative 29 plus 30? 1. So a equals to 1/5. Yay! We found the solution. We found the address to the party. Let's write a first. A is 1/5. And what is b? 6. And there you go. Okay. Don't forget, and I'll leave this up to you guys. You can also eliminate b to get the 1/5 for a. I'll leave that up to you guys. Okay, very good. By the way, if in the process of doing this, if you add this 2, okay, and somehow you get a false statement, somehow you get 0, okay? If you get something like this, 0 equals to 9. This is false. That's a false statement, which means there's no solution. If you ever get a false statement, there's no solution. And you have to say it. In this case, we didn't get a false statement. If you ever get a true statement like, for example, something like this, 5 equals 5. That's a true statement. That means there's many solutions. Many solutions. Infinitely many solutions. That's how we say it. So for this one is true statement, infinitely many solutions. The other one, false statement, no solution. Okay? Forget that. All right, done with this one. All right. Let's do another one. But now this one is going to have 3 equations. This one is going to have 3 equations. Now, if you're going to solve a system that has 3 equations, that means that each equation is going to have 3 variables, or 3 variables are going to be involved. I should say it that way instead. Okay? 3 equations, okay? 3 equations and 3 unknown. That means 3 equations and 3 variables. So watch this. By the way, this 3 equations is section 3.3. And here we go. Let's try this one. Let us try, for example, this one. Here's a good one. 2x minus 3y plus 2z equals -7. 2x minus 3y plus 2z equals -7. Okay? Yep. That's the first equation. No, 3 variables. 3 variables. When you have 3 equations, you must have 3 variables involved. Okay? Here's another one. X plus 4y minus z equals 10. X plus 4y minus z equals 10. One more equation. 3x plus 2y plus z equals 4. 3x plus 2y plus z equals 4. Okay. And there we go. Okay. Let's label them. Equation 1, equation 2, and equation 3. The first step, you pick 2 equations. You pick 2 equations and a variable to eliminate. Once you pick a variable to eliminate, you gotta stick to that variable. You are stuck with that variable. And you're gonna have to eliminate it twice. Okay? All right. Once again, you pick 2 equations, 2 different equations, it doesn't matter which ones, and a variable to eliminate. So let me see. You see this z? Z and z? Because it has negative, I think that z is the easiest variable to eliminate. Okay, so now I'm going to pick 2 equations. So the easiest equations are going to be equation 2 and equation 3. So I pick equation 2 and equation 3, eliminate z. Okay. And how do you eliminate them? How do you eliminate? You add both equations. Remember that. Okay. Equation 2 and equation 3. And equation 2 is x plus 4y minus z equals 10. 3x plus 2y plus z equals 4. That's equation 2 and equation 3. I'm going to eliminate z by adding. Okay, not a problem. Let's add. And so therefore, if you have a different pen, try a different pen, because the next equation, you're going to call it a different, you're going to label it different, okay? So add them up. What's x plus 3x? 4x. What's 4y plus 2y? 6y. The z's cancel. Equals 2, 14. Note, we have equation 1, equation 2, and equation 3. I'm going to label this one. This is what we found. These are given. The one you find, the first one, you label that one equation 4. Okay. So you pick two equations and eliminate z. And like I said earlier, you're stuck with z now. You gotta stick to z. Okay? So that means I gotta pick two different equations and I'm gonna have to stick to z. Okay? So I look at this, I see equation 1 and equation 2. These are almost opposite, except this needs to be negative 2z. Not a problem. I'm going to multiply this by 2. So that 2 times negative z is negative 2z. Remember, got to eliminate z again. You're stuck with z. Okay, no problem. Equation 1 stays the same. Equation 1, let me do it here. Equation 1 stays the same. Equation 1 is 2x minus 3y plus 2z equals negative 7. And now equation 2, remember, I gotta stick to z. I gotta eliminate z again. Equation 2, I gotta multiply by 2. Right there. Not a problem. This by 2. So what's 2 times x? 2x. What's 2 times 4y? 8y. What's 2 times negative z? Negative 2z. What's 2 times 10? 20. And now we're going to add them up. And z is going to eliminate. Okay? Add them up, and what do we get? This is 4x, and what is this? Plus 5y, and that's 0, and equals 2. What is negative 7 plus 20? 13. Okay, I came up with this one. These are given. I came up with that one. That's equation 4. I came up with this one. This must be equation 5. Okay, very good. Excellent. All right. Now, I'm going to take equation 4 and equation 5, and I'm going to eliminate a variable. Look at the equations that I come up with, not the given ones. These are the given ones. The equation that I come up with now, I'm going to eliminate a variable in those two equations. And I think I should eliminate what? I'm going to eliminate x. Look at this x and that x. This is 4x, this is 4x. I'm going to multiply one by negative. Which one? It doesn't matter. Okay, so equation 4, I'll take equation 4. These are the equations that I came up with. And equation 5, and I'm going to eliminate x. You can eliminate y. To eliminate x, I'm going to multiply one by negative. It doesn't matter which one. I decide to do the first one. Let me do the first one. It doesn't matter which one. So multiply this by negative, and you get negative 4x. Multiply this by negative, and you get negative 6y. Multiply this by negative, and you get negative 14. Equation 5 stays the same. So this is 4x plus 5y equals 13. Now eliminate x by adding the equations. Okay, that's a 0. And what is this? This is minus y. And what is this? negative 1. So y equals to 1. Okay, very good. Okay, so once you solve for a variable, then you go back to one of the equations that you came up with. I came up with equation 4 and equation 5. So I'm going to take this 1, this y equals 1, and I'm going to plug to an equation that I came up with. If you plug this answer into the original problem, what you were given, you're not going to be able to solve it. No, you got to plug it into the ones you came up with. I came up with this one and that one. I can plug that y into one of them. It doesn't matter which one. I'm going to plug it into equation 4. Okay? Equation 4 says 4x plus 6y. Y is 1. Okay, no problem. Equation 4. 4x plus 6 times 1 equals 14. Solve. So then now you have 4x. That's a 6, right? And what's 14 minus 6? Equals 8. So that x is what? X is 2. Good. We got x, we got y. Guess what we need now? We need z. Once you have solved for the variables in the equations you came up with, now you are ready to solve for the last variable. And the last variable is going to be solved by going to the equations that were given. These 3 equations were given. I'm going to plug in x equals 2, y equals 1 into one of the equations that were given. I think equation 2 is the easiest one. Look at that. Equation 2 is the easiest. So equation 2 says this, x. X is 2, look. Plug in 2 there. Plus 4 times y. 4 times 1. Y is 1. What's 4 times 1? 4. Minus z equals to 10. Equation 2. What's 2 plus 4? 6. 6 minus z equals 10. Solve for z. Subtract 6. What's 10 minus 6? 4. So minus z equals 4. So that z equals what? Negative 4. So what is the solution to the system? Solution to the system. The party in 3 dimensions. X equals 2. Y equals 1. Z equals negative 4. That's a small 4. Make it bigger. Negative 4. This is the solution. Okay? Okay, very good. So this is section, these are sections 3.1, 3.2, and 3.3. Thank you very much.